Assalamualaikum and a very good day to everyone who's watching this video. Today, our group would like to present about the divide and conquer algorithm. One of the divide and conquer algorithm, which will be quicksort. So, what is quicksort? The quicksort algorithm was developed in 1959 by Tony Hoare but published in 1961. It is sometimes called partition exchange sort. It is one of the divide and conquer algorithm. So how does quicksort work? The quicksort works by finding any element which we will call the pivot in a given array, and then we will partition the array into the three sub-array. The left sub-array has element less than or equal to the pivot. The middle is the pivot, and the right sub-array has element greater or equal to the pivot, and then we will sort the array recursively. So, what is the example of quicksort in real life? Supposedly, you have been given a list of tasks that has priorities for each item. You have to sort the item first based on the priorities. For example, we have the list here. We have eggs, bread, milk, water, meat, and detergent. The number beside them is the order of the priorities. So we will be using the quicksort to sort the list here, and it will be like this: the meat, bread, water, eggs, detergent, and milk. So why we use quicksort? For a small list, it is easy for us to see through eyes and follow the priority number. But let's say if the list of the total item has a count of 128, there are 128 item on the list with varying order. So it will, for example, if we were to use any other sorting algorithm, for example, if we were to use a selection sort has a best case complexity of O n square. So the n will be the 128, and we will need to square the 128, and it will take a long time for the computer to process. So the complexity for the quicksort, which I will be explaining later, has faster process than any other sort. So that's it for the introduction, and we will continue later.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Amir Aizat bin Rusli from PITS S1G1. So today I will explain to you about quicksort algorithm with picture diagram. So on the screen we can see there is unsorted array of element. So we need to sort it with quicksort algorithm. So as we know, the last element will be the pivot, and I will be I minus 1, and j will be in the first position of array. So the first element is 3, so 3 is less than 5, so I will be increment with 1, so I will be moved to the next position. So I equal to j, in the I and j in the same position, though is nothing happen, so j will be moved to the next position, which is 7, and 7 is more than 5, so there is nothing happen, and j will be moved to the next position. So 4 is less than 5, so I will be increment and move to the next position, and 4 and 7 will be swept. 4 and 7 will be swept. After the swap, j will be moved to the next position. 9 is more than 5, So there is nothing happen, and then J will be moved to the next element, which is 2. 2 is less than 5, so I will be increment. So I will be swapped with J. So 2 will swap with the 7. Right. So J will be stay as the last element is our pivot. Okay. The right position of the pivot is I plus 1. So I plus 1 is the next position of 2. So 5 will be moved to the next of 2, and 9 and 7 will be dragged to the right side. So the pivot has swapped the position, and we have settled the concept, which is the pivot. The right side is more than the pivot, and the left side is less than the pivot, but it is not sorted. So we'll be do the same process for the left side and the right side. So we do the same concept for the left side and the right side. So that's all from me. Thank you for listening.
Assalamualaikum and hi. My name is Ahmad Firdaus, and I will explain how to implement quicksort and how it related to the picture diagram before this. Firstly, let's remake the quicksort function. The quicksort function has 3 arguments, which is the array, the start index, and the end index. The best condition of this sort is if start is larger or equal than end, then return. This will happen at the last partition where there is nothing to divide anymore. After that, we need to set the pivot. Usually, the pivot is the last index of the array. To get this pivot value, we need to rearrange the element across the pivot by using Lomuto partition scheme to make partition for the array also return the pivot value. The partition function also accepts 3 arguments: the array, the start index, and the end index. Over here, we pick the rightmost element as pivot from the array, and we need to set a variable for the position of the index that less than the pivot will be swapped. Now, let's make a for loop with the start of the index, and the for loop will end if the index is less than n. This for loop is to check each time we find an element less than or equal to pivot will swap with p index, and the p index is incremented. If a at index I is less than or equal to the pivot, then it will swap with a at index I with p index, then increase the p index by 1. This will continue until the end value. After that, swap a at p index with the a at n. Then return the p index to tell the pivot position. After that, this function will recursively execute again, but this time is for the left side of the pivot. N will be changed with pivot minus 1 because that will be the new n. This recursion will stop until the condition where start is larger or equal n. After that, we will return back to the previous recursive function and again run the function again, but for the right side. Now, start will be changed to pivot plus 1. After it done doing the right side, it will return back to the previous recursive function and also will do the right side. This recursive function will continue until it return to the first function. Now we done implementing the quicksort, and I already explained how the implementation relate to the picture explanation before.
Complexity of quicksort. The worst case for quicksort is O(n) square. The average case is O(n) log n, and the best case is O(n) log n. The worst case occurs when the partition process always pick the first or smallest element as pivot. The worst case will occur when the array is already sorted in increasing or decreasing order. For the average case, to do average case analysis, we need to consider all possible permutation of array and calculate time taken by every permutation, which doesn't look easy. For the best case, it will occur when the partition process always pick the middle element as pivot. So in summary, although the worst case time complexity of quicksort is O(n square, which is more than many other sorting algorithms like merge sort and heap sort, quicksort is faster in practice because its inner loop can be efficiently implemented on most architecture and in most real-world data. Quicksort can be implemented in different ways by changing the choice of pivot so that the worst case rarely occurs for a given type of data. Is quicksort stable? The default implementation is not stable. However, any sorting algorithm can be made stable by considering index as comparison parameter. Is quicksort in place? As per the broad definition of in-place algorithm, it qualifies as an in-place sorting algorithm, as it uses extra space only for storing recursive function call but not for manipulating the input. That's all for the complexity.
Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Shauki bin Abdul Latif from BITS SYG1. My matric number is B03191039 and today I want to present the assignment 2 divide and conquer algorithm. Based on the discussion, our group have choose quicksort algorithm for our algorithm. Based on the discussion from my group members, we have discussed the introduction of the quicksort algorithm, the explanation and presentation using picture diagram of the algorithm, the explanation and presentation of the algorithm using the coding, and the explanation of the complexity of the algorithm. And based on the discussion, we have choose one of the algorithm from the divide and conquer algorithm that we think that is a better algorithm from the algorithm that we have choose. From the discussion, we have choose merge sort algorithm, which is we think that is algorithm better than the quicksort algorithm. What is the merge sort algorithm? Merge sort is a sorting technique based on the divide and conquer technique, which worst case time complexity being O and log n. It is one of the most respected algorithm. It divides the input array into two halves, call itself for the two halves, and then merge the two sorted halves. The merge operation of the merge sorts can be implemented without extra space for linked list. We have choose the merge sort because of the advantage. There are a few of the advantages based on the speed of execution. It has the consistent speed of any size of data to execute. The next advantage is works well on. The merge sorts can work well on any type of datasets irrespective of its size, either large or small. The next advantage is more efficient. The merge sort is more efficient and work faster than quicksort in case of larger array size of dataset. The next advantage, stable. Merge sort is stable as two elements with equal value appear in the same order in sorted output as they were in the input unsorted array. And the last advantage is merge sort algorithm is better at handling sequential access lists. And that's all why we have choose the merge sort as the algorithm that is better than the quicksort algorithm. That's all. Thank you from me.